Welcome to Digital Ship VPO webinar. Today we are looking into developments with weather routing. You'll hear about a new offering from StormGeo called Strategic Power Routing that became available for clients from from last week, sorry. We have a team of StormGeo as our guest speakers. Let me welcome them. Martin Shields, Director of Business Development, Rolf Reksten, Vice President of Rout Advisory Service, and Micael O'Brian, Vice President of Products. This webinar is sponsored by StormGeo. We encourage you to ask them questions. And we are starting off with some insights from Carl Jeffrey, founding editor of the Digital Ship and current editor of Tanker Operator magazine. Let's get started, Carl.
Okay, so the basic of strategic power routing is keeping vessels at a standard power output and fuel consumption rate. And we're going to talk about why that's the best way to keep the lowest fuel consumption over the whole voyage and the lowest emissions. So it's a counterintuitive idea that, normally if a vessel is going to keep the same speed as it goes through heavy weather and sea and currents, it's going to use more power, leading to more fuel being consumed and more greenhouse gases emitted. So we're going to talk about the opposite. So we're going to keep the fuel, the power and the fuel and the emissions constant, but we'll take the speed down as we go through heavy weather, sea and currents by making adjustments to the engine's RPM. And might not sound obvious, but it actually means a lot less fuel, which is what we're going to see later. So StormGeo has been testing the concept out over the past year, and they're going to show some of the results. First of all, we're going to have a talk from Martin Shields, who's the Director of Business Development, on the basics of routing and the developments and how that led to the idea of strategic power routing. He's based in Aberdeen. Then we're going to hear from Rolf Reksten, who's the Vice President of the Rout Advisory Service, on the concept of strategic power routing and how it helps companies to reduce fuel and emissions. Rolf is based in Oslo. And finally, Micael O'Brian, who's the Vice President of Products, is going to be on hand if you've got technical questions. He's normally in San Francisco, as you can see from the background, although he's not there this morning. And we're going to have presentations for about 30 minutes, and then there's going to be plenty of time for questions at the end. So as usual, you can put questions in the Q&A box whenever you like, and you can also see everybody else's questions, and you can upvote the ones you think are most interesting, so they go to the top. Please don't post any anonymous questions. And I'd like to invite Martin to give the opening talk. Thank you.
Yeah, good morning, everyone. Hopefully you can see my screen now.
Yes.
Yeah, excellent, excellent. Okay, what I'm going to do is I'm very briefly going to go over exactly what weather routing is or what ship routing is, and then I'm going to let my colleague Rolf Reksten explain exactly what the strategic power routing concept is and how that then works. So, I mean, what we're trying to do here is we're trying to enhance solutions in vessel efficiency while sailing. So we're trying to make the vessels more efficient, more commercially interesting to the ship operators and ship owners out there. So very quickly, go over Rout Advisory Service, go over what the weather forecast is, and then we will go into the strategic power routing and the use of constant power to enhance commercial viability. Just as a very quick introduction, what I'm going to do is I'm going to just do a little bit of history lesson that everybody can sort of relax a little bit. But it's a little known fact that weather forecasting has been around since the days of Darwin. And it was actually the days of Darwin where the word forecast came from with regard to weather forecast, because Darwin had a gentleman by the name of Robert Fitzroy, who was an admiral, and he was actually the captain of the HMS Beagle when Darwin was going around doing his theory of evolution. And what happened was that when they came back from doing that, the Admiral Fitzroy worked for the Meteorological Department of the Board of Trade, which was actually a chart depot. And the intention of them was to reduce sailing times with better wind charts. But that later became the UK Met Office. And Fitzroy found celebrity not from being the captain of the Beagle, but actually from his what he called daily weather predictions, which he then termed forecasts. So if you didn't know it, that's where the word forecast actually came from in relation to weather. because it was Admiral Fitzroy that decided that there were too many people being lost at sea in and around the UK. For example, in the 5-year period from 55 to 60, there were something like 7,500 people lost at sea around the coast of the UK. And it was in 1860 that he was given the authorities to start issuing storm warnings for the UK. And those storm warnings were done with a magical new invention called the electric telegraph. Now, things have changed a little bit since then, because what we're talking about here is a weather forecast, not the actual weather. We can't change the weather because the weather has been here forever. The weather has been here since the planet was actually invented. But where does that evolution come from, and where does it actually put us? And is it an evolution or is it a revolution? From our perspective, we're looking at an evolution of the ship routing side of the business, but a revolution on the data side and the artificial intelligence that is used to determine what the weather forecasts are. Again, a little bit of nugget of information, but weather forecasting, nuclear testing, and space exploration are the 3 biggest users of the world's supercomputers. So those sciences, if you like, are the ones that drive the development of supercomputers, because they are so intensive when it comes to actually determining what is going to happen in the future. On the technology side of things, that has undergone a revolution in the recent years. But ships still remain crewed by humans. So it's still a human being that has to operate that ship. It's still a human being that has to actually operate it in a commercial sense from shore as well. The overriding requirement of a ship routing service is to ensure the safe, efficient arrival of the crew, the vessel, and the cargo. That is absolutely 100% fundamental. The ship has to arrive in one piece. The vessel has to achieve the goal of getting to its destination safely with all the cargo intact. Exactly what the requirement is in terms of the balance of efficiency versus speed versus the consumption of the vessel, that's a whole different concept. And I mean, that's a separate presentation in its own, because what we're doing here is we're only going to be concentrating on how you make the vessel more efficient in terms of the power that the vessel has to use. So it's an evolution and it's a revolution married together. It has to be the safe and efficient arrival, and it's our job to marry these 2 technologies together. So what do we call that? I mean, we tend to call that, StormGeo, we call it professional ship routing. So we look at what is available in terms of automated software, automated systems, where exactly is the vessel. Now, that information has improved greatly over the last few years. You have AIS, you have automated data reporting, you've got manual position reporting. So you've got a large gamut of information, if you like, coming from the vessel, both physically reported and automated. But as anyone in the data game will tell you, more data does not necessarily mean to say that things are more accurate or more efficient. All it means is you have more data. You have to do something with that data. You have to, if you like, commercialize it, or you have to be able to scientifically use the data to come up with a result, not just have more data. So how do we do that in terms of the ship routing side of the business? So the human side of ship routing. What we do is we employ the people that have a skill set to be able to deliver a shore-based routing service. So by shore-based, I mean it's coming from the shore and the information is being sent to the crew on board the vessel. So the personnel working on shore have to be suitably qualified. They have to have a meteorological qualification, and they have to have some form of seagoing experience. It is fundamental that they have an understanding of the people that they're actually dealing with on board the vessel. So they have to have the tools, but they also have to have the human element. So we have to ensure that they're available, first thing, 24/7, 24/7, 365 days a year. They have to be available. Initially, when ship routing started way back in the 50s, everybody was based in the United States. But as a company, we've now grown and we now have, if you like, expertise sitting in 3 different time zones of the world. So we have a team sitting in the Far East, we have a team sitting in Europe, and we have a team sitting in the United States. And they can cover the world very easily on a 24/7 basis. And they all come, as I said earlier, with the correct qualifications to ensure that they can handle all the requirements and all the questions that will come, not just from the vessel, but also from the vessel operators. Because the vessel has to get to its destination, but the operator has to have a commercial oversight as to what that vessel is actually going to do. How do we do that? So we give them the tools and we give them the systems to best support, if you like, their seagoing colleagues. We like to look at the ship routing side of the business as being teamwork. It's a team between who's on board the ship, who's actually sitting on shore commercially operating the vessel, and then who is providing the route optimization information, if you like. How do we do that with the personnel? We make sure that they are qualified and trained and have an expertise that focuses either on the area that they're servicing, so which part of the world they're servicing, or the type of vessels that they're servicing. So in the back end, we break everything down into bulk vessels, tanker vessels, container vessels, and then ro-ro vessels. So those are the main, if you like, vessels that we're working with. And we have something like, I don't know, 3,500 ships underway at any one time. But they're divided up into different teams, and they're also divided up into different areas of the world. And as they become more qualified and have more experience, then they get moved from easy areas to service into the more difficult areas like the North Pacific and the North Atlantic in winter, because those areas require a greater expertise and knowledge of how to operate a ship and how to get a ship across the ocean. What we're looking at with the strategic power routing, which is what we'll get to very shortly, is that that is available not just on a cross-ocean passage, but it's also available on a coastal passage. Because what you're doing is you're not just optimizing the track, you're actually looking at what the speed of the vessel is and what the power requirement for the vessel is. So it works both cross-ocean and on coastal passages. So the shore-based personnel are given a whole array of information that simply couldn't be delivered on board the vessel at this time. Technology has improved greatly and many vessels have VSAT, but still you're going to have access to far more information onshore than you will have on board. We take that data, we analyze it, we then work out what the capability of the vessel is, or the vessel's response will be as she sails through the different weather and climatic conditions, how she'll respond, and then how much she'll consume and what her ETA will be. And we can then deliver that actually on board through a simplified optimization software. So how exactly does it work? So Rout Advisory, I think everybody knows, or everybody that's on this call will probably understand exactly what the Rout Advisory Service is. But again, it has to be a discussion and teamwork between those people sitting on shore, those people on our side, the people operating the vessel, and the crews on board. So we do that by sending initial message to the vessel prior to sailing. And the intention and our desire, if you like, is to start a dialogue between the crew on board and ourselves. So we find out exactly what the requirements are. We find out exactly when they need to arrive, and we find out exactly what the commercial considerations are for that passage. Once the vessel is underway, we ask the master to report to us. We get access to any digital data that they may have being reported automatically. So we may be speaking to a charterer, we may be speaking to an owner, we may be speaking to a manager, or a combination of all. And then we take all the data that is available and allows us to review where the vessel is, what the forecast is for the next 15 days. We will then service that vessel every 6 hours. So every 6 hours, we will actually run the forecast that is just updated through the system to find out where the vessel is, where the vessel will be, and whether we need to update the vessel with a new recommendation or a new weather forecast. And that happens, like I said before, 24/7, and it's overseen by human beings as well as by the systems and the back end software, if you like. It has to be a balance. As a company, we see this as a balance between artificial intelligence, between automation, between incoming data and the human element. We know that in 20 or 30 or 40 years' time, ships will be automated, the same as planes will be automated. That is going to happen whether we like it or not. But for the next 10 or 15 years, the human element will remain on board a vessel. The human element will remain as the vessel operator. So it has to take precedent, if you like, in the way that we communicate and the way that we actually service the vessels when they're underway. So that brings us to strategic power routing. And I will hand over very, very quickly to my colleague, Rolf Reksten, sorry. I want you to look at this as that it's the evolution of routing. So it's an evolution of routing, but it's a revolution with regards to technology. And with that, I will be quiet and I will hand over to Mr. Reksten, and he will hopefully take the screen away from me and carry on.
Thank you very much, Martin. I hopefully am sharing my screen shortly.
Yep.
Yeah, bingo.
Bingo, thank you very much. Okay, good morning, everybody. Thank you very much for that introduction, Martin. I think it's quite clear to us that this is still, although there's been a massive technological advances and there's an evolution in terms of how things are done, this is still very much a people business. And Martin illustrated quite clearly how once you've established a route or a track that the vessel is going to sail, whether that be cross ocean in an optimal and pre-planned way, or coastal, you then want to focus on the vessel's efficiency along that track. And strategic power routing addresses that, and we'd like to try and give you some analogies that will work for you with regards to how to understand our approach with regards to this. Where's that? So for this purpose, we've tried to use a car, which most people understand how it works, and use this as the best possible illustration of what we're doing. So a car has a gas pedal and accelerator, as the Brits say, and a vessel has an RPM setting, which would be illustrative of the same thing. In terms of a car, we have a maximum power, and in a vessel, we have an MCR, a maximum continuous rating, or the load, as it's sometimes referred to. If, like on the left-hand side of this screen, you're driving your car along basically a flat road, you'll be trying to maintain, you press the gas pedal to maintain an RPM of 2,500 RPM in this example. You will have a constant power output, as well as a constant consumption, which is ideal. If then you start to go uphill, like on the left-hand side of the screen, you'll have to depress the gas pedal more to maintain the same RPM and maintain the same speed. Consequently, the power will go up, the required power will need to go up, and the corresponding consumption from the fuel will go up. And this is we try to translate it into an example where we're looking at the left-hand side of the screen again and can't see, the RPM remains at 90, like in the illustration of the car, where it's ideal we have a constant power and a constant fuel consumption. But then on the right-hand side, you start to meet the weather as is the real life situation. And traditionally, you want to maintain the speed orders are given, or RPM orders are given, and you want to maintain the same RPM. But in this virtual uphill scenario at sea, the power will need to be increased, and the corresponding fuel consumption will need to increase to maintain that speed. So what strategic power routing does is that it allows the RPM to fall. And with the RPM falling as you're meeting weather conditions, the power remains the same, The consumption remains the same and predictable, but of course, the vessel will reduce speed. The speed will be affected by this, and it will go slower in these conditions. So how does this enhance the vessel efficiency? If we look at a situation where we're trying to maintain constant power, constant RPMs, and the white line here is illustrative of the weather conditions. I think maybe that's disappeared behind the pictures of our colleagues here. But the white line represents the weather factor, and the red line represents the MCR, or the load. And you're maintaining a constant speed order, you'll have to follow the weather pattern as is illustrated here. This will mean that the consumption goes up and the efficiency of the vessel is reduced. In this illustration, the ETA of the vessel is on the 15th of September, as we can see in the bottom left, right here. Going to a constant power by keeping the power in this case, at somewhere around 57%, and following the weather, the vessel will go faster and slower, but we're not trying to beat the weather, and we arrive 1 day later in this example on the 16th. This is because we allow the vessel, the RPM, to come down, and we allow the vessel to go slower. All of this is taken into account when the pre-plans are made. I'll get into that a little later. In our systems, on our dashboard systems in S-Insight, as we call it, you can chart these occurrences as the voyages are being completed. And this was an example of a vessel under strategic power routing in the trial that we've been conducting for the past year. Now you can see that the power variance, the red line here, is very narrow. It's only 8%. And that the consumption on this passage has been very linear. And this is what we're after. A linear consumption is predictable and it's efficient. Contrary to that, another vessel which was not following a strategic power routing, you can see that for this longer voyage that the variance and power as the vessel met the weather is 20%. And of course, that means that the main engine consumption goes up and down correspondingly. So what are we actually providing in strategic power routing compared with traditional routing? We're still producing a route suggestion and a weather forecast, as Martin described. This is still a manual process where we're providing data and information to the vessel and the interaction there. We are providing a pre-voyage planning. The pre-voyage planning for strategic power takes also into account all commercial considerations, like what is the preferred ETA? Are there economics around the voyage that need to be taken into account before choosing on an optimal speed and setting that will be recommended to the vessel? And this pre-planning stage uses our proprietary algorithms in terms of speed loss and stuff with regards to the specific vessel in question, which allows us to give an RPM advisory. Now, the RPM advisory is a predictive RPM setting, revolutions per minute setting, that allows the vessel to change the RPM. So it's variable in up to 6 hour intervals, so up to 4 times a day, to maintain the constant power setting. Now, do we take into consideration the charter party speed and consumption? It's important to note that this way of ordering your vessel voids any CP warranties. So if the vessel is on charter and it's not your own vessel, you will be voiding your CP warranties by using a service like this. And correspondingly, you won't get an analysis report or an end of voyage report, as it's sometimes called, on the CP terms. You can, however, get an end of voyage report or a performance report basis the ordered speed or speeds, depending on how that's changed through the voyage because of commercial considerations like ETA. There is, of course, no legal aid or support because there's no CP warranties to relate it to, but we do provide an ROI to validate the value of the service. In terms of how the information is provided to the vessel, this is a constant power table, which is sent. It's a longer document, but I've snipped out 2 examples here. where you can see in the top table what the suggested RPM settings are on these 2 days in question here, and the corresponding constant power. And then there's a graphical representation over a longer period of time, showing quite clearly how the red line, the RPM, varies as you meet the weather and the forecast to maintain the constant power. And the important thing to understand is that we're providing predictive RPM setting information along the forecast, allowing the master to set the RPMs so that he can maintain that. So it's a proactive rather than a reactive instruction. In order to order this service from us, there are some requirements. A lot of them are very standard routing requirements. We need to know what kind of vessel it is. We need to know the load, the laden condition, laden or ballast, the cargo type and quantity. All this relates to safety. And we need to know the arrival window or the laycan if it's going towards a load port, so that we can provide suggestions which meet these commercial criteria. We do provide forms that need to be filled in. Some fields are obligatory and some are not. The optional fields will assist us in assessing the vessel, and so that we can give them best possible instructions to the vessel. And ideally, we would like the owners or the client's speed and consumption tables and slip tables if the same are available. Slip tables indicate speed loss dependent on slip, and will give us an opportunity to fine-tune our numbers when we're sending out instructions to the vessel. So and finally, to wrap it up, in this trial that we've been conducting now, I think maybe the numbers are disappearing behind our pictures, or maybe it's only my own screen. But we used 23 routes, sorry, of which 12 routes followed the strategic power routing. 11 did not follow. 11 that did not follow were either too short voyages, or there were other commercial constraints that didn't allow it to be followed. And there was a couple of instances where there were some engine issues, so that they didn't follow for that reason as well. The cost, there is an additional cost to this value-added service of $150 per route. So in this case, the 23 additional routes cost the client $3,500 US. We saved on the 12 routes that followed SPR, we saved 260 metric tons of CO2 at a total value of $26,000 and change. Either way you break this down, it's an adequate savings compared to the investment or the cost related to this. And this comes on top of the value of routing the vessel and choosing the optimal route, where that value is greatest is, as we know, on cross-ocean passages. But as Martin alluded to, for all passages that are coastal or where there is no real choice in terms of the route, the standard shipping lanes, for example, this service does optimize the efficiency of the vessel anywhere you meet the weather. So these are additional savings in both your CO2, your greenhouse gas emissions, and monetary savings that are worthwhile taking with you as you go. Today we have going towards a zero and decarbonization. We have to try and save everything everywhere we can. So this is a contribution to that, and I hope you found this presentation so far interesting. So I'll round it up there and open up for any questions that you might have.
Oh, well, thank you very much, Rolf. Yeah, this I guess the thing that came across to me was how complicated this is for shipping companies, because there's so many different incentive schemes. You've got the charterers, you've got IMO things, you've got companies got their own things they want to do. I noticed that the IMO rules and EEXI are on the ship itself. It doesn't even cover this kind of stuff, and then the chartering stuff is very expensive, very complicated. What do you think? Do you want to maybe use a warm-up question before we get to these very difficult questions on the Q&A? How does the incentives work when you talk to your customers? Is it mainly companies want to do this, or are they actually looking at the actual money values of it, or is it? I guess it varies with every customer, does it?
Well, I think what the trend is in the market, whether they are owned owned or chartered vessels, and certainly with regards to chartered vessels, the clients are wanting to operate the vessel outside the CP warranties. This is because this varies geographically. It's different in Asia than in Europe, but in Europe and America, they're seeing a greater value in operating the vessel at the most efficient way possible, contrary to coming up with a claim and trying to recoup some money because of non-performance there. At the same time, this decarbonization and reduced CO2 emissions is come for real, and people are looking at any way possible to reduce that. So, and by operating a vessel more efficiently in any shape or form beyond your CP warranties is then something people are looking at more actively now. And this comes in under that umbrella.
Wow, that sounds great. Well, we've got 12 questions. I guess we'll just go through them in order, but if anybody wants to upvote anybody's question, then it automatically goes to the top of the list. We'll start with Micael O'Brian, who's a maritime consultant in Stockholm, from his LinkedIn page. So he's asking about this balance between the charterers, what the charterer is looking for, how you balance that against what the master is looking for. I think you kind of answered that, didn't you? Would you say?
Yes, I suppose yes. I mean, there's an RTA and the ETA. The RTA is more for the container industry and is a well-proven way of getting that with using strategic power routing on that as well. For the ETA, there's always a certain movement in that goal, and obviously it's the safety and of the crew and the vessel and the cargo in that order. It is the primus driver here.
Oh, okay. So if we go to Benjamin's question, so 3 upvotes. Well, I guess a simple question. So you use less punctures, but you arrived a day later. So how do we weigh that up? I guess it's a complicated balance issue.
It's a very relevant question. Obviously, losing a day at sea has an opportunity cost with regards to the following cargo and the value of that following cargo. If you're taking one more day to steam to the point, all our ROIs, our return on investment calculations, take that into account. So when we assess the savings, we do add in and penalize the savings along the actual route with the time lost and the fuel lost. So if a vessel arrives a day later, she consumed a whole day's extra fuel. That's taken into consideration. But the net balance is part of the algorithms in terms of which choice you actually make. So that is taken into consideration in the pre-voyage planning.
Oh, okay. So Abhirami Selvaraja, 3 upvotes. So he's asking, do you take the freight rates and the bunker prices into account? I'm not sure which of you is best to answer that. Maybe is it a commercial question for Martin, perhaps? Is it?
Martin, do you want to answer that?
Yeah, I mean, we have to know what the rate. I mean, we don't need to know what the rates are, but we can take it into account. Again, the strategic power routing is aimed not at the out-and-out charterer. Primarily, it would be aimed at the owner-operator of the vessel. I mean, the charterer can use it as well. Depends how much control they have over the vessel. But yes, I mean, we can take into account the daily hire and the bunker consumption as well, or the bunker prices as well.
I can expand on that briefly, just a second, Carl. In the pre-planning stage, a series of speed alternatives are established. We can add bunker price and the higher rate to those so that you get the sort of the least cost, the best PCE equivalent alternative. If that still matches your ETA obligations, then that is the obvious choice to take. And that takes into account the current value of the voyage and the future value of the vessel or the demurrage value at the discharge port. So we can take those commercial considerations into account.
Wow, okay. So now we've got a question from engines from Nikos Bekiaris. Where'd you get your estimate of the main engine power needed? Is it from the fuel oil consumption or for a different RPM? I don't know, Michael, you were engines expert. I think you're a weather expert, not an engines expert, is it?
Yeah, no, I could take a look at this. So this is the top question here.
Yeah.
How is the main engine power needed and being estimated for different weather conditions? Is that the question?
Yes.
And
yes.
the MEs for fuel consumption from different RPMs. Yeah. So what we're doing is we get the baseline data typically from Lloyd's Sea Web, right? So we have this relationship between the rated speed of the vessel, the MCR power, and the RPMs required to make that MCR. We also realize that that Lloyd's data is not necessarily up to date, right? Because over time, the ship could be derated. There could be some kind of a change to a turbocharger. So what we like to do is have access to the latest data from the ship, and in particular, if we work with the captain or the operators to have access to a slip table, which will give us very relevant information in the relationship between speed and power and how the weather is going to influence those parameters.
Wow. Okay. So we've got a cheeky question next from one of your competitors here. I think this is for you, Martin. Why are you charging extra for this service? Surely it should be included in your. Do you want to?
I mean, primarily because it takes more time, more effort, and we're also we are having to advise the vessel, and we can change the recommendation every 6 hours, every 12 hours, every 24 hours. So there's a lot more communication involved. So the effort, if you like, okay, you can do a lot of it through automation, but the effort still has to be communication with human beings through the three parties involved.
There is often a discussion between the vessel and our RAs about the RPM settings, etc. So there's a greater cost to serve with this, which is updated daily, 4 times daily, in fact, and so that's the reason there's a minor additional cost to that.
Oh, okay. So next question from Micael. Maybe this is for Michael. So when you're working out the savings, you were comparing with a standard route, or you're comparing with the route the master came up with? How is this savings calculated?
Yeah, so I guess there's 2 dimensions to that, right? We look at it from the route dimension, which is like when Martin was presenting. We look at the traditional weather routing, and we have a long history there, of course, where we're able to take a look at what the master had intended to do for a particular route and what we're recommending for that passage. So for that dimension, it's quite easy for us to come up and say, along the StormGeo recommended route, these are the results, and had the vessel proceeded along a different route, this is what would have taken place. That's the first dimension. The second dimension is what Rolf alluded to in the second part in the presentation, which is now building on top of those already impressive savings that we get from weather routing. We're now able to say, if you follow these power recommendations to maintain that constant power and allow the ship to organically slow down in increasing weather conditions and come back up when the resistance on the hull is reduced, that we get additional savings. And we measure that essentially by knowing what the actual results of the voyage were and comparing it to what the traditional response is to heavy weather, which is the application of more power and higher consumption. So we have the ability to reference a ship-specific fuel curve to help us, make those calculations for return on investment.
Okay, maybe we'll stick with Michael for the next one, since you know about the fuel curves. I don't know, Raju must be talking about an issue. I don't know, it must be if a speed and consumption table is provided by somebody else other than the owners. I guess this must be some commercial issue, which I'm not familiar with. I don't know, how do you deal with this?
So this is that top question. How would you deal with the time chartered vessels where speed and consumption tables may not be provided by the owners? Well, yeah, we've actually worked with time charterers in our trialing, and we do find that if the time charter doesn't have access to that data, then perhaps there is data on board the vessel that can be used to help supplement this. But in the absence of that data, we do have access to the raw Lloyd's data, which is going to give us, like I said earlier, that reference between rated speed, MCR, and RPM. It's not the ideal situation because, yeah, if the vessel was derated, the engine was derated, or if there was some degradation in the power of the vessel over time due to natural wear and tear of the engines, the results might not be as optimal as if we had the slip tables. But so far, we're finding that on board the vessel, we've been able to get the appropriate data to make this as valuable as possible.
Oh, okay. And the next one looks like one for you as well, Mike. It'll be something different. Why aren't you recommending in real time? Why do you wait 6 hours to send an update?
Well, I mean, the weather forecast models that we've been talking about globally, whether it's the European Center for Medium Range Forecasting, ECMWF, or the GFS model in the US, which are the two principal global models, they're only produced every 6 hours. And since we're basing our calculations very heavily, of course, on the predicted weather in the future, as well as the ocean currents, we're not going to have anything dramatically different to offer inside of 6 hours, because we need to see what that next forecast is bringing.
Oh, okay. So the commercial question is this for you, Martin, maybe. So if the vessel needs to be chartered for another day because you're taking a day longer, are you balancing that against your savings and your fuel cost? I think you are.
I can actually answer that one, Carl. The answer to that is yes. If we lose a day, let's say you've lost a day of some future value, that is taken into the calculation, as well as the fuel, the extra fuel that's used on the actual voyage. So both items are taken into consideration. We are aware that there is an opportunity cost to losing time.
Okay, and I don't understand the next question, the limits in weather, water depth and coastal areas you use for performance monitoring for the charter party. Is that does somebody understand?
That's a kind of odd. I mean, we take into consideration pretty much all of the weather and all of the forecast data and the water depths and coastal forecasts, but I don't know what is meant by the limits in weather, because like Mike said, it's a 6 hourly update. You can interpolate between forecasts, but it's still, I'm not 100% sure what is meant by that.
Okay, maybe
I might be able to take one quick stab at this. I don't know if this is relevant or not, and the person who asked it will know, I suppose. But when we talk about thresholds, we talk about thresholds for the safety of the vessel, the cargo, and the crew, and then we talk about CP thresholds for "quote unquote" good weather. And of course, the CP good weather thresholds are defined in the charter party itself, and the thresholds that we take in terms of safety, we get from the operator, but also from the captain directly, and hopefully that helps answers the question.
Okay, so if we go to Harry Verhoeven's question, it looks like a charter party question. If you've got to stay quite closely to a critical RPM within a small range, how do you handle that? I guess this sounds like another question about this whole charter party thing, is it? Maybe looking at Harry Verhoeven's question at the top.
Well, I think I know what he's getting at here. We have a range of RPMs. We have a maximum RPM and a minimum RPM typically, and in between you could have unusable ranges that we need to be aware of. So we might have like an MCR RPM of say 90, just for example, and we might have a low end of 55, and there could be an unusable range between 62 and 66 for whatever reason. And what we do is we do identify those regions. So if our recommendation on the power or the RPMs to achieve that constant power dip into that unusable range, we would either keep it above the unusable range or it would drop below. We would definitely respect that critical RPM range.
That's a technical issue of the engine, not a charter party issue then, by the sound of it.
Yeah. I believe so, yeah.
Okay, so Florent Violaine is asking, if you don't have a speed consumption table, how do you estimate it? Is that this Lloyd's table you go back to there? Is that one for you, Michael?
Yeah. So we would use the raw data from Lloyd's CWeb, which is which we know is the data at the delivery of the vessel, and that's quite reliable. It's good, but we just strive to get this added layer of information because it does enhance the quality of the service overall. But we've had good results without the slip tables.
Okay, so if we go to Petrie's question, I think this is also for Michael. So he's asking if you're modeling wave added resistance. I'm sure you are, as one of the best weather routing companies.
Yeah. So Yeah, we're modeling. Yeah, we currently are using. We have access to two data sets, right? We have the GFS, the Global Forecast System, and with that we have a wave watch model that we evaluate, and we also have the ECMWF and the wave model data that comes out of that system. We actually do some proprietary work to extrapolate the different energy feeds that come out of the ECMWF, and we collate those, I guess you would say, into what we would in shipping generally consider a wind wave and a swell, based on the wave period and the energy, etc. So absolutely, yeah, it's a key function in what we do, and this is what brings, I think, extreme value to what we do, in the fact that we're looking at this from a very technical perspective, but when we're doing all these predictions into the future, it's based on this highly technical weather and speed loss data that really makes the recommendations and the forecast of power and RPMs into the future relevant.
Oh, sounds great. So maybe Benjamin Weber's question, maybe is that for Martin? And he's saying, so we can go slower and arrive later without using your speed SPR service. But what if we just do that compared to if we adjust the RPM? I guess it's a bit of a cheeky question because it depends on the specifics, I suppose.
It's always. I mean, if you sail slower, if you sail slower, you're going to consume less and you're going to arrive later. That's kind of obvious. But what we're trying to do here is that a lot of the time, ships will sail at a set RPM, and they won't fluctuate that RPM. That RPM will remain constant. So they'll do 98 revs all day long, every day, because that's what they've always done. And the trick with the SPR is that you retain the power setting, but you vary the RPM. So yeah, I mean, you still, if you reduce, if you reduce speed, you reduce power, you go slower, then you will arrive later. But the whole idea behind SPR is to adjust the RPM, but keep the power constant. So you're not going to have those fluctuations.
Okay, so we've got two questions about your products now. John Morton Klingsheim is asking, are you using Norwegian Coastal Administration advices about routes for the last mile? It's a bit out of scope, that question, but maybe you've got some comments. And then Thomas Sandmo is asking, why don't you make this happen automatically rather than giving the crew a choice about it? I don't know which one of you is best to answer. Maybe it's time for Rolf, is it, to answer? As a Norwegian? Or?
Well, I'll take a whack at the first one there myself. So this last mile thing, of course, the routing service in its traditional sense, when you're looking at how am I going to get from New York to Hamburg, is typically an at-sea service, right? But what we're looking at here, we do have services, and it's really not out of the scope of this particular discussion, but we do have services that are looking at not only the at-sea portion of the voyage, but the maneuvering and the import activity as well. So you could understand fully various efficiencies in regards to engine performance when you're maneuvering seaboard and Earth. And I'm not entirely sure if I'm hitting the mark on that question. If I don't know if Martin or Ralph think I might be missing the mark there at all. Yeah.
Okay, I'm not sure either, Mike. But I can have a stab at Thomas Sandmo's question about automation. I think the dynamic question there is, are you going to move this kind of instruction from the bridge to shore? Technically, it's probably possible to automate this. There would have to be a very, very high level of confidence between the parties before something like this actually happened. But there are some advantages to it. But then you have the practical stuff in the machine room. How much RPM adjustments will the chief engineer accept, for example, at nighttime when he's not on duty? This kind of small minor detail would have to be addressed in terms of bringing the actual automation to shore before anything like that could happen.
Wow. Okay. So new question at the top of the list from Massimo. So he's asking about the best route for CO2 production, because I guess these different things, because there's different fuel costs and different seekers. There's routes with lowest CO2 and routes with lowest fuel costs. Is that I'm not sure which of you again is.
Yeah,
I can have a stab at that too. We do have a lowest cost scenario. Okay, lowest cost by default means fewer tons of fuel. Okay, assuming that the market is not massively above the daily fuel burn cost or value, put it that way. So in general terms, yes, your lowest cost scenario on the fuel will be your lowest CO2 production.
Yeah, and if I could just add maybe a little bit, Rolf, is like you mentioned earlier, we have the pre-plans, and the pre-plans are very specifically going to speak about the expected fuel consumption on various routes. So if your motivation for a particular voyage is to keep the CO2 at an absolute minimum, the option which would produce that for you would be quite visible in that data set.
Oh, so we're going to Leonard Sederberg, who's an entrepreneur and marine meteorologist, according to his LinkedIn page. But he's saying he was doing recommended power in 2014. What part is new? Martin, your business development manager, is that for you?
Morning, Leonard. How are you doing? I know Leonard from days of old. I think the biggest difference now is we have access to so much more information. This old revolution in terms of the amount of data that you get allows you to do this. So, I mean, Mike spoke about the data that we get from Lloyd's, but we also, as a company, we route something like 12,000 different ships every single year. And a lot of those ships are sister ships. A lot of those ships are built in the same yard. They have the same type of engine. So you can actually glean information from those vessels. So even if you're lacking information from a particular vessel, you can look at sister ships with the same engine. So you can mine that data far more easily now, which gives us far more confidence in our ability to be able to determine what the proper power settings are and what the RPMs are that go with those power settings. Of course, everything is dialogue. The more information you have, the more accurate a calculation you can make. So the biggest difference between now and then is just the fact that you have so much more data that you can actually use. Again, commercially, you have to be a little bit careful what information you use, what is commercially sensitive, what's given out to third parties, etc. But yeah, we have far more information that we can actually base those calculations on now.
And if I could make just one quick comment there too, I mean, we've actually been doing constant power for many years as well, but it was directed mainly towards the liner industry in terms of a fixed ETA and helping those ships achieve the optimized fuel consumption basis that are required time of arrival. And I think the main difference here is that we're now looking at it in terms of the shipper industry, where it may not necessarily be a required time of arrival. It's more of a commercial speed to operate the vessel at, and then tailoring the technology to allow constant power while trying to look at a particular speed in COMSEAs as opposed to a fixed arrival time.
Oh, okay. So we go to Robert Corden's question about charterers. So I don't really understand this part about charter party warranties, but he's also saying the charterer will enjoy getting much more accurate predictions about the time it's going to arrive and how much he's going to use. I'm not sure what the specific question is in here, but does anybody have any?
I can have a stab at that. Charter party warranties are guidance warranties as to the performance of the vessel. They're not always motivated by transparency and accuracy. They are a guidance which the vessel is intended to meet. Now, in terms of strategic power routing, we check that out the window. We don't consider it at all. But yes, you're absolutely right. Transparency would be useful, and it would be very to everybody's advantage to have a better view of what the vessel's actually consuming than in some cases we have today.
Oh, okay. We're running short of time, but maybe we'll just go quickly over these questions. This question about integrating with Lee Marine, I think that's a bit out of scope, talking about a competitor, so maybe we'll pass on that one. Amar Singh is asking for an explanation of the last slide. We'll have this all on video, so hopefully you can watch the video there. Ranveer Jattar is asking, can you get the same constant power by just using a propeller shaft torque meter? But I think it's the modeling, not the actual keeping of the constant power that's important. Jacob Everson is asking if you have a cyber attack. Bodnath Prasad is asking, maybe I should read these questions before reading them out. Does anybody have any comments? Well, I'll read some more of these questions if on these.
I mean, the cyber attack and the weather data, I mean, we have access to, like Mike said, we have access to ECMWF and NWS. I mean, I would be very surprised if both of those fell over all at once. It would be virtually impossible for that to happen. We have backup systems in the US and in Europe. So we're not dependent on one thing in one place.
Well, it's 3 upvotes question. So Luke is asking if you've got fouling, which is changing the models of the ship performance curve. How are you modeling that as you go along? Is something that's quite interesting, I think, isn't it? I don't know.
Yeah. Well, yeah. So for a long time, right, our service we provided is the ability to understand how the vessel is performing relative to an ordered speed and consumption or a charter party speed and consumption. So if the vessel is indeed fouled, and we understand that she's ordered at 13, but she's really only performing at 12, so her speed is down by a knot, but she's actually still consuming the fuel for 13 knots. We'd be able to take that ratio and extrapolate it out to the different operating speeds, and make sure that it's being fully accounted for in the services that we're providing. Absolutely.
Oh, okay. So questions of what ocean currents forecast are you using? How do you account for the direction of changing in the swell and wind? Are you suggesting is there something? We've only got 4 minutes left, but I don't know if there's something you want to pick up there in the last couple of minutes.
Sure. Yeah. As far as the ocean currents, yeah. I mean, I started as a deck officer back in the late '80s, and we used the pilot charts, of course, and it's. As Martin was talking about in his presentation, things have improved dramatically. Let's say that much, right? Now we're using satellite-derived analysis of ocean currents and predicted ocean current analysis or forecasts, and we're using HICOM as our principal forecast model, but we have access to other data sources as well. So that's the hybrid coastal ocean model, which will not only take into account deep sea ocean currents, but the ocean currents behavior on the continental shelf and in near coastal areas where you're going to have tidal influences.
There's a question here from Nikos about, is SPR suggesting alternative routing or just alternative RPM? I think it's a relevant question because the routing is the routing, and that comes with the package. So the optimal route for the vessel, given the weather conditions, is established, and then along that route, the SPR comes into play. So you're optimizing along that line. If you're sailing a coastal track like Martin talked about earlier, where there is no route alternatives, you would still be able to use SPR because you meet the weather wherever the weather is. So in general terms, for any passage where an optimal route is valid, that is first taken into consideration, and then strategic power routing along that route optimizes the vessel's efficiency along that route, not just the choice of route.
Oh, that's all fantastic stuff. There's a very interesting question from Jarno, which picks on whether or not your customers actually accept your recommendations or they don't. And you said in the last slide, it was basically showing that half the customers, I don't know if it's too strong to say they didn't accept them or they.
There were very good reasons for those vessels not following it. We do have a series of alerts because our clients want to know. They're instructing us to give the vessel RPM instructions. We are doing that. If the vessel is not following those instructions, which they've been ordered to follow, they want to know about it. So we do have alerts for that purpose. And for the most cases, the instructions are quite clear. In the trial period that we had, there were a number of passages which were not followed. As I mentioned, there were various reasons for that. They were either too short. There was one vessel that had significant engine trouble, so we lost out on a lot of passage. We just couldn't do it. There were 3 vessels allotted for this trial, and one was out of commission for quite a period of time. And then there can be other ETA type of or constraints where they just have to speed up and go like a bat out of hell to make a cancelling date or whatever. So the things that were inhibited the vessel to follow. It's not a question of them not being ordered to follow that if possible. These are speed settings. These are not route settings.
Oh, sounds great. Well, we've plunged at plan to finish on the hour. We can circulate the questions around the speakers to see if there's any they'd like to take up in written form, but I don't know if any of the panelists have any burning questions they'd love to answer, or from the last minute or so, anything you'd like to?
Well, I do see a friend of ours here, maybe Johannes on the top of the list here. How do you derive a permissible RPM range under bad weather conditions for RPM suggestions? So that permissible range is typically by design of the vessel. So we're taking that the upper range from the Lloyd's Sea Web or from the captain for a particular voyage, and then we typically understand the minimum operating RPM. And then for vessels, there can be one or multiple unusable ranges that we would have to get as well, and then we would take those into account.
Oh, okay. Rolf or Martin, I don't know if there's any particular questions you'd like to answer. We're going over time now, so we can send you the questions on a spreadsheet afterwards, and you can have a look at later if you'd like. But
yeah, I just want to say I noticed there's a few questions about how you actually apply it, how you apply SPR, how you apply weather routing. But I mean, weather routing, optimum ship routing always takes into account all the conditions that the vessel's forecast to encounter. So whatever the ship's going to encounter, we then calculate what the speed loss will be. It doesn't matter if it's following, beam, head conditions or whatever. We are always going to take that into consideration. There seems to be a lot of questions around the charter party, and the charter is doing one thing and the owner is doing a different thing, and the two never meeting. But the whole idea of SPR is to try and increase the communication in the operation of the vessel as a whole, as an entity. So we're going to have the owner on side, we're going to have the master on side, we're going to have the charterer on side. Everybody has to want to do the same thing. So your time, the vessel may be underway longer, but the whole idea is to cut on the consumption side. So it all comes back to, how much is it going to cost my vessel because of the time versus the fuel. So we have to get everybody around the table, if you like, to discuss that, rather than everybody sitting in their own little wee camp.
Oh yeah. Rolf, do you have any final words you'd like to make?
There's a last question here from Melbourne Pinks. The SPR reports don't replace the noon report. Vestlink is a noon report or a noon reporting system. They don't replace that. This is an instruction which comes from land to the vessel as a guidance for the RPM settings only, with the weather forecast and all those things. So it doesn't replace the vessel's requirements to report a noon report. No.
Oh, that's great. Well, that's been a phenomenal number of questions, 27 questions. That's I guess probably we're best to finish on time because people have other commitments, but I'll pass back to Vida for the closing words. Thank you.
Thank you. I observed a great attendance today, 220 of you watching, listening to us. We are grateful for you tuning in. This Thursday, we are talking about making maintenance data easier to integrate. Feel free to join us as usually 10 a.m. London time. Hopefully we'll see you. And now Digital Ship is signing off. Take care. Bye.
Bye-bye.
Bye.
Excellent. Thank you very much.
Thank you.
Bye.